Good morning, friends. Today we are going to start the new unit and the next unit of the analytical chemistry. That is the unit 3. The name of the unit 3 is the optical methods. In that we have to see the 4 different types of the techniques. First one is the your atomic spectroscopy. Second one will be the molecular spectroscopy, and fourth one will be the molecular fluorescence and phosphorus spectroscopy, and the third one is the turbidimetry and the nebulability. These three part of them means total we have to see the 6 techniques. Okay, out of this we will discuss here the important part which we have to see during this lectures or say during this unit. The unit 3 optical methods, I said first part is the atomic spectroscopy. In that 2 techniques we have to see. One is will be the flame emission spectroscopy and another one will be the atomic absorption spectroscopy. First we will focus the introductory part, then the energy level diagram, atomic spectra and absorption and emission spectra, flame photometry. Then we have to see the principal instrumentation of that part. As atomic absorption spectroscopy, its principal and the instrumentation part we have to see. Then the quantification methods that are used in the FES and AS we have to comparatively see. Then comparative study between the FES and AS that we have to see its application, advantages and limitations. That is the first part atomic spectroscopy involves. Then second part is the molecular fluorescence and phosphorescence spectroscopy. In a molecular fluorescence and a phosphorescence spectroscopy, we have to see the introductory part, then its principle, the relationship between the fluorescent intensity with the concentration, the factors affecting that particular fluorescence phosphorescence, is its instrumentation. 2 techniques will be there, fluorimetry and phosphorimetry, and comparison with the absorption methods. And the last part of this unit is the turbidimetry and an fluorimetry. In the turbidimetry we have to see again the introduction, the techniques we have to see its principle, then which factors affects the scattering of the radiation. There are certain factors given: concentration, particle size, wavelength and the refractive index. This part we have to cover under this particular unit. Now we will move further to the our main topic, optical methods. Now here in the atomic spectroscopy we have to see the 2 techniques. One will be the flame emission spectroscopy and another one will be the atomic absorption spectroscopy. The name itself indicates that flame emission spectroscopy, the name itself indicates that there will be the flame. Which flame will be there? Means we have to use the flame, and after that absorbing the heat energy, any atom or say elements will absorb the heat and it will get emitted. It gives the emission energy. Then second technique is the atomic absorption spectroscopy. In that we should know this particular thing, absorption will be there. Suitable amount of the wavelength or the suitable wavelength or the suitable frequency will get absorbed and then it will gives the transition. Now in the FES we can start that. FES, here the study of the radiant energy emitted when an element heated in the flame is studied. Okay, what we are studying in the flame emission spectroscopy, what happened, that the study of the radiant energy which will emitted when an element is heated in the flame. Means we have to first of all hit the element in the flame and it will gives you the, it will emit the radiant energy that we will measure. The flame converts the element into their atoms, which when they get excited, after what will happen, first of all the elements will convert into the atom, means the atomization will be there, and atomic once the atom form it will get excited. These excited atoms emits the energy and falls to their ground state. What will happen? They will absorb or say they can they will excite by absorbing this heat energy from the flame, and they will emit the some sort of the energy that is called as the emission and falls to their ground state. The excitation of the atoms is due to the transition of the electron of the atom from lower energy level to higher energy. The energy required is provided by the high temperature of the flame or by the electrothermal means you can use the electrical thermistor also for the that particular heating purpose. You got this point? What is there? We have to see the basic difference in between this Fs and S. Then the lifetime of the excited atom is very short. Of course, when the atom is in the excited state, it is a short lives. This is a short period. Hence, it loses its energy by the emission of the radiation, and atom returns to its ground state. When the emitted radiation is examined in the spectrometer, distinct frequency lines are observed. These lines constitute the atomic emission spectrum of the element. What will happen when the emitted radiation is examined in a spectrometer? Distinct frequency lines are observed. These lines will constitute the atomic emission spectrum, atomic absorption spectrum, and the atomic emission spectrum of the element. Here emission is there, that's why the emission spectrum is there. When the absorption will be there, at that time it is the absorption spectrum. You got this particular point, FES. It is a very simple. We have to heat the element in the flame, then that element will excite, that element get the heat energy, and it will convert into their respective atoms, and this atom will get excited. This atom is excited due to the transition of the electron in the atom from the lower energy level to higher energy level. The energy required is provided by high temperature of the flame or by electrothermal means. Got this point? Very simple it is, and you can record. We are using the spectrometer, and you will get that spectrum that is called as the atomic emission spectrum. Now, as in the S, it involves the study of light that has passed through a flame containing atoms of an element. What will be there? Study of the light that has passed through the flame containing atoms of element. The atoms in the flame absorb the frequency of characteristics of their own characteristics. They will absorb. Example, copper will absorb radiation of frequency 3 to 4.7 nanometer. If the light emerging from the plane is analyzed in the spectrometer, a spectrum consisting of a dark line is observed. This spectrum is called as the atomic absorption spectrum of the element. For example, any atom will absorb radiation of the 589 and the 589.6 nanometer. These are the examples. You got this point? What will happen? Absorption means in the flame you have to pass the light, okay, and it will get absorbed. Which light will get absorbed, that we will monitor by using the spectrometer, and it will gives you the dark line spectrum. It is called as the atomic absorption spectrum. Earlier case we have talked regarding the atomic emission spectrum. Okay, are you getting this point? Very simple. These techniques are. Then the energy level diagram. Energy level diagram shows the electronic transition from one energy level to another. Emission and absorption for the radiation involves the interaction of the matter and the radiation. A study of interaction of matter of radiation is based on the electronic structure of an atom and a molecule. The following figure gives the energy level diagram for the sodium and potassium. First of all, we will talk about the sodium. In the sodium, you know, the electronic configuration will be the 1s2, 2s2, 2p6 and the 3s1. The 3s electron will responsible for the excitation. Okay, it may transfer to the 3p, it may transfer to the 4d. That may transfer to the 4p, 5p likewise. This is shown here. The excitation energy in the electron hole has been shown 0, 1, 2, 3, 4, 5, 6. Here their levels are there. You can see the different atomic absorption that particular is observed for the sodium. Here the explanation is given. When the sodium atoms are exposed to radiation of 539 and 589 and 589.6 nanometer, the valence electron 3s in the atoms absorb this photon and will raise to the 3p level. The excited electron return to the 3s level by emitting a photon of definite energy. The electronic transition are 3p to 3s, 3d to 3p, and 4p to 3s. These different wavelengths are given. The most intense lines are those corresponding to the 3p to 3s transition at 589 and 589.6 nanometer. That are the yellow D lines, and their ionization potential is given 512 electron volt. You got this point? These transitions are shown. Different transitions are there, and their wavelength has been shown, but the intense lines is that these are shown in the dotted line and it is shown in the dark line. This is the 3s to 3p that has been shown, 589.6 or say 589.0 nanometer. These are the two distinct wavelengths are there. Means here it will get absorbed and then it will get gives you the back to their emission. Then similarly for the potassium atoms are exposed to the radiation of the lambda 767 and 769 nanometer. Okay. The valence electron in the atoms absorb this photon and will be raised to the 4p level. The excited electron return to the 4s level by emitting a photon of definite energy, and the electronic transitions are 4p to 4s. Okay, or you can see the 4f to 4, that 4d to 4p is there, and 4f to 4s, 4p to 4s is there. The most intense lines are those which corresponds to the 4p to 4s transition at these two particular wavelengths, 6769 and 767, 767 and 769 nanometer. It is called as the red potassium doublets, and the ionization potential is the 4.432 electron volt. One important thing is given that the electronic transition can be regulated by controlling the flame temperature using the suitable fuel and oxidant gases. It is very much important. Okay, here this is the introductory and the basic part of these two techniques. Very simple it is. In the APS we should know there will be the emission of radiation. How it will get emitted? First of all, we have to that heat molecules in the flame, it will absorb the suitable radiation and will get excited. Means molecule will form the atom. Means first of all, molecule will get converted into the atoms and atoms will get excited, and this atom will get excited due to the transition of electron. That you should know. Okay, then what will happen once they excited? This is the short life. They have the short lives in the excited state. They return to the ground state and emits the suitable radiation. It is called as the emission. And if you record it on the spectrometer, or say you can examine this particular radiation using the spectrometer, you will get this particular spectrum is called as the atomic emission spectrum of that particular element. Similarly, in the AS that we have seen, here will be the absorption of what? When you are hitting that element or say molecule in the flame, at that time we are passing the light through that particular element, and it will absorb the characteristics frequency or the characteristics wavelength of their own and will get excited, and it will gives, and that whatever that particular light emerging from the plane is analyzed in a spectrometer. A spectrum consisting of dark line is observed. This spectrum is called as the atomic absorption spectrum of that element. Got this particular point? Then energy level diagrams, it will show the electronic transition of the electron from one energy level to the another. Then emission and absorption for the radiation involves the interaction of the matter and the radiation. The study of interaction of matter of radiation is based on the electronic structure of these atoms and the molecules. Two examples are there. One is the sodium and another is the potassium. You can see that electron will gives you the two characteristics wavelength, that is the 589 and the 589.6 nanometer. Same case is applicable for the potassium, and it is called as the that particular lines, that is term it as the yellow D lines, and where for the potassium it is denoted as a red lines or the red doublets is there, that observed at the 767 nanometer and the 767 or 7 and the 769 nanometer. This wavelength you have to remember, at this particular wavelength they will absorbed. Okay, these are the characteristics wavelength of these elements. Means you can, if the mixture is there, if in the sample there are so many elements, we can identify based on these particular values, because the each and every element has different that their characteristics wavelength. Got this point? And I said the last, that is a very much important. Electronic transition can be regulated by controlling the flame temperature using the suitable fuel and oxidant gases. That you have to remember. Very simple part it is. Please prepare it well. If you are not getting, you can ask me. If you have any doubt, you can easily ask. But these two techniques are there, very much important. The question will be there. If you know this, what is the difference between these two techniques, then you can easily interpret the answer, and you should be able to write the answer. Please see this, please write these notes very well. If you are not getting, we will see the one by one. These two techniques are very much important as the exam point of view. The three questions will be there based on these. Two questions will be there on the fluorescence, and one question will be there on the table perimetry and nephelometry. Please prepare this AS and APS techniques well. And if you are not getting any part, you can ask it on the WhatsApp group, or say when we are meeting online for the discussion, at that time you can ask. If you have any in this unit, all the theoretical part is there. You have to remember the diagram, you have to remember the spectrum, and then you have to interpret in your own. If you are writing that part in your own word, then it will gives you the more weightage, and the more that particular you will get the good marks also during the exam. Please go through this video well. If you have any difficulty, any doubt, you can freely ask. FES and AS, these are the two important techniques. Their comparison, we have to say, their quantitative method involves in this particular FES and AS. We have to see, then we have to see the principle and the instrumentation of this FES and AS. Then we have to see the comparative study of these two techniques, its advantages, limitations. Okay, that all we will part see one by one. Today we will stop here. because this is the introductory part of this unit. Okay, but important part it is again, sometimes the main question will be there on this particular, explain the energy level diagram, or say in the this atomic spectroscopy using the suitable example. Thank you.